Hello everyone. In this video, I'm going to discuss about features of Java. Okay. So here, these are the list of features of Java. These features of Java. So we can also called what Java buzzwords. Okay. So Java buzzwords we can call. Okay. So we can discuss one by one. So why Java is simple, why Java is secure, why Java is portable, like that. So we'll discuss one by one. Okay. So Java features are also called Java buzzwords. Buzzz words. Okay. Java buzzwords. Let me discuss what one by one. Okay. See, first one, Java is what simple. Okay. So how you say Java is simple? Okay. See here. In Java, the main confusion concept is pointers. Okay, this is eliminated. Okay, this is eliminated. This pointers concept. Okay, we have in C and C++. So this confusion concept is eliminated in Java. So Java is free from pointers. Okay, Java is free from pointers, and if you have this pointers concept, you may have security attacks. Okay, so you may have security attacks because of this pointers concept. So this pointers concept is eliminated in Java. And if you are familiar with C or C++ programming languages, it is easy to learn Java. Why? Because in C, C++, we have basic syntaxes like what for loop, okay, while loop, and conditional statements like if else, okay, and switch cases, all these, okay, whatever the basic syntaxes we have in C and C++, all are imported, okay, all are imported to Java. So that's why, because of these reasons, okay, Java called as simple. Okay, so what first point to tell Java is simple is, in Java, pointers concept is eliminated. Pointers concept is eliminated, and the basic syntax is whatever. Okay, so we have used in C and C++, these basic syntaxes. Okay, while loop, for loop, and if else conditions, and switch cases, all these are imported, imported from C and C++ to Java. So that's why we call Java as simple. Okay, now let me move to the next feature. Okay, so secure. Okay, so how you say Java is secure? Okay, how you say Java is secure? Here, Java does not depends on operating system runtime environment. Okay, C++ or C uses operating system runtime environment. It depends on the C or C++ depends on the operating system runtime environment. But Java does not depends on OS runtime environment. It has its own runtime environment. Okay, Java runtime environment. Okay, so who will provide this Java runtime environment? Java Virtual Machine provides what this runtime environment for your Java program. Internally, JVM provides security to your application. See, Java provides internal and external security to your application. This internal security is provided by the JVM. Okay, how it provides security? Why? How means, see, source code in C and C++ directly converted into the machine code. Okay, machine code. But in Java, source code converted into the byte code, not directly into the machine code. This byte code is interpreted, okay, interpreted by the Java Virtual Machine. While interpretation, Java Virtual Machine is going to what check this byte code. If there is any harmful code is added to the byte code or not. If is there any harmful code added to this byte code, then immediately JVM going to what JVM is going to raise some security exception. Okay, security exception is what thrown by the JVM at runtime if there is any harmful code is added to the bytecode. If there is no harmful code is added to the bytecode, then only it will interpret the bytecode and then convert it into the machine code, then execute. So this is the internal security provided by the JVM. And external security, if you want to provide external security apart from the internal security, then you can use cryptographic techniques. Here, encryption plus decryption, these two techniques collectively called cryptographic techniques. What is encryption? Converting from plain text to ciphertext is called encryption. What is decryption? Converting from ciphertext to plain text is called what? Decryption. Here, okay, sender is going to send what a message in encryption format. Means convert plain text to ciphertext. Here, plain text means human readable format. Human can read this plain text. Ciphertext means human not able to what read ciphertext. Okay, at receiver side, reverse process will happen. This what a ciphertext is converted into the plain text at a receiver side. Okay, so plain text means human readable format. Okay, so like this, Java provides two levels of security. Okay, one is internal security, and second one is external security. This is the most important feature of the Java. Okay, this is most important feature, that is platform independent. So while development, uh, while Java development, okay, so the main aim of the Java team to develop this Java is to make Java as platform independent. Okay, so Java is platform independent. Means Java programs are not depends on operating system. Here, platform is nothing but operating system. Java programs are executed by any operating system, irrespective of its development and compilation. Okay, here it does not depends on operating system. Already, I told in previous feature, right? So it has Java has its own runtime environment. Okay, Java does not depends on operating system. Okay, so here Java code, okay, Java code compiled into C bytecode. This bytecode is executed by executed by any operating system. Okay, any operating system. Here, see, any mission with JRE can run Java programs. Okay, so any mission with JRE. So if you install Java runtime environment in your system, and you are able to execute Java programs. Okay, so bytecode you can execute by using this Java runtime environment. So here what so here this bytecode not depends on the operating system. Simply it depends on the Java runtime environment. Okay, JRE. Okay, so here JVM. Okay, so JVM is depends on the operating system. JVM is platform dependent, but any JVM can understand this bytecode. Okay, so OS to OS JVM will be changed, but any JVM can understand this bytecode. So that's why Java is platform independent. Okay, see here, see Java program converted into bytecode, not into the mission level code directly. Now this bytecode is interpreted by JVM in a Linux operating system, and this is interpreted by JVM in Windows OS, and it is also interpreted by JVM in Mac OS. This bytecode, bytecode is understood by any type of JVM. JVM is OS to OS different. Okay, JVM is OS to OS different, but this bytecode is understood by any type of JVM. Okay, any type of JVM. That's why Java is platform independent. Does not depends on the operating system. and Java is portable. Why? Because see here, write once, run anywhere. This feature makes Java as portable. Why? Because it does not depends on the operating system and it does not depends on any hardware. See here, bytecode and JVM in Java makes Java as platform independent. Already I told in the previous feature. Okay, so Java bytecode can be carried to any platform. Platform means operating system. Okay, operating system. So no implementation dependent features. Okay, there is no what implementation dependent features. So we have different versions of JVM for different platforms. Already I told in previous what feature, right? So for different operating systems, different JVM is there. But here, see, Windows machines have their own versions of JVM. Linux has its own, and Mac has its own versions of JVM. So if you distribute your bytecode to any mission, JVM of that mission would translate bytecode into respective machine code. Okay, already I explained about this entire thing in previous slide. Okay, so write once, run anywhere. Okay, this feature makes Java as portable. Okay, so without any platform dependency, you can execute your Java program in any operating system. So you can move your Java program from one system to another system. Okay, so that's why Java is portable. Next, Java is object oriented. Okay, Java is object oriented. See, Java is pure object oriented programming language because everything we write in Java comes under classes and objects. Okay, so whatever you write in Java, okay, that is comes under classes and objects. Okay, so Java is pure object oriented programming language, but it is not 100% okay object oriented programming language. Only the reason is whatever the primitive data types we have used in C and C++, same what primitive types we are using in the Java. So only because of this reason, Java is not 100% object oriented. Okay. So what are the basic concepts of object oriented programming language? So class and object, encapsulation, abstraction, inheritance, polymorphism. So I have made separate videos for all these concepts. So you please go through my lectures. There you can find so separate lectures for all these object-oriented principles. Okay. Next, robust. Robust means strong. Okay. So Java does not allow to crash your programs. Okay. So Java does not allow you to crash your programs. Okay. Okay. So in Java, see, Java programming language is robust, which means capable of handling unexpected termination of program. Unexpected termination of program. So if your program terminated unexpectedly, then your program does not crash and your hardware also does not crash because Java is robust and it is capable of handling unexpected termination of your Java program. There are two reasons. Okay, first reason is Java is have what exception handling mechanism, default exception handling mechanism. Okay, so that is the first reason. And second reason is Java has automatic garbage collection. Okay, automatic garbage collection. So because of these two reasons, what Java is robust. See, there are two reasons behind this. First, it has most important and helpful feature called exception handling. So if there is any exception occurred at the time of execution, okay, at the time of execution, then what happened? Java automatically handle that exception. Okay. So how Java handle that exception? JVM is responsible to handle any type of exception in Java. Okay. JVM is responsible to handle any type of exception in Java. Okay. So this is what default exception handling, and we can have our own explicit exception handling. So that I have discussed in a separate lecture. Please go through that lecture. Why we need to handle exceptions explicitly, even you have what a default exception handling mechanism. Okay. So Java is robust because of this first reason. Java has default exception handling mechanism. Okay. And another reason is Java is strong lies in its memory management features. Java has default garbage collection mechanism. Okay. This default garbage collection is also performed by the JVM. See, in Java, okay, if there is any what unused objects, okay, if there is any unused objects, then these unused objects are unreachable objects in your memory. These are identified by the Java virtual machine, and it is going to perform cleanup operations. Okay, cleanup operations, and it is going to what reclaim the garbage about your Java program. Okay. See here, in low level language, there is no default garbage collection mechanism. Java provides runtime garbage collector offered by the JVM, okay, which collects all unused variables. Okay, here variables, okay, should replaced by objects. Okay, so here unused or unreachable objects are collected by the Java virtual machine at the time of execution. Okay, next, multi-threaded. So this is very important feature of Java. So multi-threaded. See, Java multi-threading features makes it possible to write program that can do many tasks simultaneously. Okay. So by using multi-threading, so you can perform many tasks simultaneously. Okay. Simultaneously, you can what run what many tasks related to a program. Okay. So benefit of multi-threading is to utilize what same memory. We in other terms we can also call it shared memory. Okay, shared memory and other resources to execute multiple thread at the same time. Okay. So example is while typing, grammatical errors are checking along. See, for suppose if you open Word, okay, MS Word, if you try to what type something, so it is going to what check the grammar, right? It is going to check the grammar. So here you are typing something, and at the same time, grammatical mistakes also checked by the what word pair. So simultaneously, typing and grammatical okay mistakes are checked in the what word pair. Okay. Next, another example is so if you consider online examination, okay, online examination. So there you should have timer, right? Why? Because online exam means you should have what limited time period. So there you should display the timer, okay, timer along with the what QP, along with the QP, right? Along with the QP. So QP, okay, displayed, and you are going to look at the QP, and you are going to answer the questions in QP as well. You are going to look at the timer also. Okay, you are going to look at the timer also. Here, timer, okay, running at the same time, and it is going to the application is going to display the question paper at the same time. Okay, so this is multi-threaded. Okay, multi-threaded. Yeah. Next, architecture. See here, Java programs are does not depends on the any processor. Okay, any processor or any hardware. If there is any processor upgrades in your system, okay, does not affect the Java program. Okay, so Java programs are does not depends on the processor. Okay, so if there is any processor upgrades in your system, okay, if there is any operating system upgrades also, so it won't affect the Java program. Okay, see here, any operating system upgrades or processor upgrades, okay, and changes in core system resources, okay, all combined to make a what a program malfunction. But in Java, this problem was overcome. Okay, so is any upgrades in the operating system or processor or any what upgrades in the system resources, it won't affect Java program. Okay, it won't affect the Java program, but in other programming languages, it may what affect. Next, interpreted and high performance. Okay, see, unlike in other programming languages, already I discussed. Okay, so unlike in other programming languages, so source code, okay, source code is converted into the bytecode. Okay, converted into the bytecode. Then this bytecode is interpreted, then converted into the mission level code. So when compared to C, C++, okay, when compared to C, C++, see the program Java program execution very first time is slow. Why? Because of this intermediate code generation. This intermediate code generation here, intermediate code is the bytecode. Okay. Once your program is converted into the bytecode, then in JVM we have a separate part called JIT compiler, just in time compiler. So this just in time compiler, it is going to interpret your bytecode and convert the bytecode into machine level code. Okay, convert it into the machine level code. Here, JIT compiler will speed up your Java program. So here, what JIT compiler will do? JIT compiler, okay, every time it is going to check your bytecode. If your bytecode is not changed, then it is going to execute the previous machine level instructions converted by the JIT compiler. So, okay, converted by the JIT compiler. It is going to okay execute this machine level code, which is already executed converted by the JIT compiler. Okay, only whenever Java program okay came for execution, okay, very first time, then only it will take much time for execution. Okay, from second time onwards, okay, this JIT compiler is going to speed up the execution of the program. So this is the interpreted and high performance feature. Next, Java is distributed. Okay, so by using Java, so we are able to develop distributed applications also. Okay, so if you want to develop distributed applications, okay, your programming language should support TCP/IP protocols and the HTTP protocols. Okay, TCP/IP and the HTTP protocols. Here, Java supports both the TCP/IP and the HTTP protocols. Okay, and Java achieves distributed features by using RMI and socket programming. RMI means remote method invocation. Okay, remote method invocation, and socket programming is okay. So this is also what this by using socket programming also we can what create a client server applications. Okay, client server applications. Okay, so yeah. So here Java is distributed because it supports TCP/IP and HTTP protocols. Why? Because if you want to develop distributed applications, your programming language should support this TCP/IP and HTTP protocols. These two protocols are supported by the uh, Java, and here distributed features are supported by Java by through what RMI and socket programming features. Okay. Next, dynamic. How is the Java is dynamic? Java is dynamic language. Why? Because you can load Java programs or Java classes dynamically on demand. Okay, so you can load your Java programs what on demand. So whenever you require, okay. So if you have what a JRE in your system, simply okay, you can load your Java program and execute. Okay, execute it. And Java okay also supports some native functions like C native functions from native languages from what are the native languages C and C++. Okay, so in JVM we have native method library is one. Okay, native method library one part is there. So this is used to execute what this native functions from C and C++. So if you go through the JVM architecture, then you have this native method library part. So I will discuss JVM architecture in separate video. Thanks everyone. Thanks for watching this video and please subscribe my channel for more videos.